What I'm going to do is I'm going to show you an example of how we solve a non-homogeneous second order differential equation. But in this particular example, what I'm going to do is I'm going to give you an example where we have a linear particular integral as part of our working. So I'm going to show you the question. I want you to pause the video and have a go at it, remembering the steps we've discussed previously, and then come back and check what you've done against what I'm going to show you as my working and my solution. Here you go. So there's the question, finding the general solution to that. What I want you to do is pause the video and have a go at it. So first part, I want to find the complementary function. So in order to do that, what we have to do is rewrite this such that we get m squared minus 7m minus 10 equals 0. Remember, we get the complementary function from solving the homogeneous version of the equation. Then we get the particular integral by looking at the next part. So if I've got m squared minus 7m minus 10, if I factorise that, I get m minus 5, m minus 2, which means I get solutions of m equals 5 and 2. What that then means is my complementary function, let's call it g of x, that's equal to a e to the 2x plus b e to the 5x. That's a nice, simple, straightforward way to do it. Second part is we want the particular integral. Now remember, what we want to do is choose the format of a particular integral such that it matches up with this. Now this here is a linear particular integral, so what I'm going to do is I'm going to choose y equals ax plus b. What I now have to do is differentiate it once and then again such that I can get the answers and substitute them into here. So if I substitute that, I get dy by dx equals a. And then obviously the second derivative, d2y by dx squared, of that is 0. So what I now do is I substitute all of this into this equation here, such that I'll get 0 minus 7 times the first derivative, which is a, then minus 10 times the original equation y, so times ax plus b, and that is going to equal 20x minus 4. So what I now do is I sort this side here such that I can equate the coefficients to the numbers that are here and solve for the a and the b. So if I multiply out this bracket here, what I'll end up getting is minus 10ax. I'm then going to have minus 10b minus 7a, so I'm going to put that in a bracket. So I'm going to have minus 7a plus 10b. Now I know that that equals 20x minus 4. So what I can say from that is by equating the coefficients, so I'll equate the coefficient of x first. I can say I've got minus 10a is equal to 20. So a is equal to minus 2. And if I then equate the second terms here, I can say that 7a plus 10b is equal to negative 4. So if I take that, I then get 10b is equal, so I'm going to have negative 4, take away 7a. Well, 7a is negative 14. So I've got negative 4 minus minus 14. So negative 4 plus 14, which gives me 10. So from that, I can say that b is equal to 1. So then my particular integral, let's call that h of x. What I can say to you is that h of x is equal to negative 2x plus 1. So from that, I can tell you the full solution is y equals g of x plus h of x, so my complementary function plus my particular integral. And if I solve that, what I then get is y equals a e to the 2x plus b e to the 5x, then add on this here at the end. Taking the signs into account, I've then got minus 2x plus 1. So that there is the general solution to this equation. Now if I were given conditions in order to find the particular solution, this is the point where I'd use those conditions. So I'd get one condition for y equals and another condition for dy by dx equals, both at the same value of x. So that tends to be the way the conditions are given to you. What we then do is use both of these to get a pair of equations in terms of a and b, which we can solve simultaneously to get the values for a and b, and then substitute back into that equation there. So that's how we'd get rid of those arbitrary constants if we had it. However, we want the general solution. We're going to have the arbitrary a and b in that solution, so that there is the final answer for this example.